tonight we're gonna go ahead and make the first trial pin for this Certa-Flat welding table. This is the 3648 fab block from weldtables.com, and hopefully you enjoy the video, and if you were looking for something to get started, I think these are pretty handy. Hey guys, got something I'm working on I wanted to share with you. What I've got here is some 5/8 diameter 1018 steel, and what I was thinking was making some quick little, I don't know what these things would be called. I've never had a welding table with fixturing capabilities before, but for lack of a better word, I'm just going to call these things like studs or pins. So what I was thinking was I take the 5/8 diameter 1018 steel, and then I maybe cut off, we'll just say 2 inches for now. I'll cut a series of these off. So let's go ahead and mark this every 2 inches. I'll do a couple as a trial run. And then what I'm going to do is just take my portaband, my portable bandsaw, and cut these off. And then I'm going to take some more 1018 steel, and I've got that in a 1-inch diameter. That way I can go ahead and locate these things, you know, wherever I need a pin dropped, I can do that. I'll use this as the pin to actually fit inside of these holes here. These are 5/8 diameter holes. Actually, I think they're like 628 thousandths or so. And then let me see here. Oh, anyway, so I think these are about 628 thousandths. This is 625 thousandths, and then we'll have a pretty decent fit. It will allow a little clearance just to get in and out, and if there's any slag or something in the hole from the laser, if there's any of that, then they'll work. So the whole point of this thing is to be able to do some quick, accurate layouts. And the reason I was thinking 1-inch for the outside diameter of the top part of the pin would be so you have just an easy number to work off of. So these have a 5/8 diameter hole spaced exactly 2 inches on center apart from each other. So then you know when you drop a 1-inch slug in here, you can work off that real easy. So I like the 1-inch diameter, and you're going to need something from letting it drop all the way through anyway. So that's what I'm going to go with. And yeah, we'll just make a couple and see what you think. Another thing I want to show you, this is not on that same subject, but I think it's pretty cool. So you probably notice I put everything on casters around here because I have a really tiny shop and way too many tools and projects and everything else going on. So I found these casters on Amazon. Obviously these things aren't like super industrial, but I think they have a capacity of each caster to like 200 pounds. So this is like an inch and, I think it's an inch and a 5/8 diameter wheel, and then it's got an actual standoff or leveler on each one of these casters. So you get a 4-pack of these bad boys for about 15 bucks. I think this is ridiculously cheap for the value that adds. So as long as you're going to be putting these on something that doesn't weigh a shit ton, you're going to be fine. So anyway, really cool find. I wish I would have found them earlier. If I find some larger ones, I'm going to buy the heck out of those while they're available, because I'm constantly building stands for things, and what a nice feature to have, to be able to roll it into position, drop your levelers, and get this thing stationary. It's a perfect example of the of what I actually should have for this. So last week you probably saw the video for that 3-in-1 press brake slip roll and shear, and I made that stand for it. Well, you know what, when you go to use that thing, you don't want the casters rolling, and even if you have locking casters, it's still going to shift a little bit. So it would be much better to go with these guys here and be able to lower these down once you get it into position and have something fairly sturdy. So anyway, happy with the quality so far. Obviously I haven't installed them on anything yet, but I can tell that the construction is at least as good as the Harbor Freight ones you buy, and they're probably, they're less expensive than it would be to buy the same ones that I put on that shear last week. So yeah, what a great little find. I'll post a link on Amazon for those little guys below. All right, so I'm gonna kind of draw my idea so you guys can visualize what we're gonna be doing here. So like I said, we're gonna be taking that 5/8 diameter stuff and doing the deal with it. Grab a pen here. So I've got a couple of these made now. Shouldn't say made. I've done a couple of very rough cuts with the Portaband. Just marked them quick with a Sharpie and cut them off. So there's no real tolerances held there at all. But we've got 4 pieces, and just to show you kind of how the fit is, it's in here. There's just a hair of wiggle. So if you were to shove really hard on this, it could rock. But as long as the 1-inch diameter piece that's going to be shouldering and slipping down and basically touching against the flat surface of the table, you shouldn't have a hell of a lot of rocking like this. So I'm gonna hopefully that adds some stability to this. This amount of slop isn't, it's not a lot. So anyway, I think for fabrication, as far as like welding things up, this would be acceptable. As long as you had constant pressure against your pins, then this slop would be eliminated by, say you wanted to do a 90-degree or whatever. You could have 2 of them here, as long as your piece was shoving up against that, and your next 2 pins that were wherever they're going to be here, and then 1 more to the side. As long as everything's held tight, it will eliminate that slop. So there goes 1. Now, how this is going to go down, I will have one of these pins. Can't even draw a straight line. We're going to have one of these pins, and then we'll have our 1-inch diameter. I don't know how tall I'm going to make this thing. I'm probably just going to make 1 or 2 or 5 and see what I think. And then what I was thinking of doing was having these recessed into a bore in that 1-inch diameter material. So we basically leave these suckers in their raw form, other than maybe cleaning them up a bit, getting that factory crap off of there, and then do a press fit into the 1-inch diameter piece. I think that'd be pretty slick. So again, this pen's not working too hot, but I've got another one in my pocket. So I guess as a asymmetric view of that thing, the 1-inch diameter would be like this, and then it would have a slightly under 5/8. I don't know what diameter I should use for this. I'm gonna have to mic these and see what they actually come out to be once they're cleaned, and then I'll make this probably 2 thou under that, or whatever the press fit should be. I'm not sure. I have not done a lot of press fitting, but I'm assuming it's probably about 2 or 3 thousandths. You'd probably want that to be over. And then if you want to do an interference fit, you could preheat your 1-inch diameter piece and chill your 5/8 diameter male part, and then stick it up in her. Yep. So that's the plan. Let's see what we actually do. All right, so we've got some inexpensive digital calipers here. These are cheap, but I found they're actually pretty damn accurate. So let's check our bore dimension of the table. So right there, I don't know if you can see that well, but I'm getting about 633 thousandths, and .633. I'm sure as I rotated this, I'll probably get a slightly different size too. I've got 635 there. Let's go around here. 635. So looks like 633 is probably going to be my small. 630. 632. So we'll just say we're going to get on average about between 632 and 635 on diameter of these holes. I'm not going to measure them all, but that's what I'm getting here. So let's measure what these actual pieces come in at from the factory here. And I get 623. So it's actually a 10 thousandths difference. That's significant. I'm still going to make some and see how the fit goes and see if it works out good. Because, man, would that be convenient to not have to really machine much and then just pump a couple of these things out. Well, we'll see what happens. So you've got that. The shaft diameter is, throw that on there again, 624, 623, 626, 622. There's a lot of crap on this too, so we'll just call it, call it 623. Not that that matters because we're not going to be machining this down. And then bore size, that we'll try to machine this down to 6. Let's say 620 as a tentative, 620 thousandths tentatively right now. You know what? Let's take a time out on that little 5/8 diameter piece and let's focus on getting one of these bastards prepped. This is the 1 inch diameter guy. I want to get one of these set because I'm thinking of just drilling a hole with this drill bit I've got on the tailstock really quick and then doing a quick trial press fit deal. And I'm using the world's cheapest indexable cutters right now. This one's actually set up for doing threading, but I'm gonna give it hell. See what happens. It's actually kind of hard to get in and get a really nice view while filming. I gotta be honest, I'm not crazy about having the tripod wrapped up around what I'm trying to work on either, but I guess it's just a sacrifice for making these videos. Alright, so that is machining great. I've actually got that faced off enough to where I could call it good. I'm going to take just a hair more though. I want to make sure the whole surface is flat. So, if you're new to machining, let me shut this off. If you're new to machining, you'll notice that when people are operating the lathe that they only bring it across halfway because since the work is rotating towards you, the cutter only has to cut half of the diameter and it's going to be getting the other end of the work too. So that's why we're always only going to the center and then backing back out. So once we back away, you'll know if your tool is centered properly or not, because if it is too low or too high, actually you can end up with a little, what we call a nipple in the middle of the work. Let me get in closer so you can see. So you'll see on this piece, get it to focus there, we don't have much of a nipple because the cutter itself right here is centered properly on there. Okay, now that I've got this part faced off, what I'm going to do is go ahead and get a center drill set up in this tailstock. I've got a 3-jaw Jacobs chuck here, and then I'm just going to come in here, do a quick center drill. I'm going to put a little bit of cutting oil here, and I'm going to turn, that's at 755 RPMs. That's good enough. So I'm going to get the tailstock pretty close, and I'm going to lock the tailstock. I'm going to go ahead and just go in. This will allow our drill bit to be centered in time. Alright. That's a good start. I'm going to back this out. This drill bit's a 29/64. Put a little bit of oil on that guy too. And we're also going to slow this machine down. I'm going to go down to 460 RPMs really quick, because that'd be a little fast, I think. You'll know if this is too fast, it's going to squeal like hell. We call it chatter. Okay, so eight, 3/16. Quarter. We're going in, we're 5/16 now. And 3/8. I think 3/8 is pretty good. What do you think? Now, we've got a hole inside of that guy. Let's talk about what we're going to do now. I say we take a quick measurement and see where this hole is as far as its inside diameter. Now, this was done with a drill bit. To do this very accurately, you'd want to follow up with a reamer, but we're not going to do that. We're just going to make it work. I'm getting about 461, 462 possibly. We'll call it 462. So I'd like to make that part that's going into here 465 thousandths. So let's write that down, because the inside bore with that drill bit happens to be, we'll say 462 thousandths. So like I said, we started off with this as the general idea, but we've already switched. So this was an ID inside diameter of 600 and what was that? I think it was 622. Just verify. Just make sure I'm not losing my mind here. $460. $61. Jeez. Yeah, let's call it 462 thousandths. I'm going with the the largest number because I don't want to go with the smallest one and then have the shaft, you know, be wrong. Actually, I should be going to the smallest. 462. Well, we're going to go with the male end OD 465. See how that fits. So we're gonna make that 465 thousandths. It's not a good idea to store a bunch of crap up here on top of your lathe. It's not a tool stand, so don't do this. But if it's your shop, you do what you want. But it's really not ideal. It's a bad example to set for people that are trying to learn how to do this. All right. So let's pop our part back out of here. And since I'm here, I'm going to clean up this guy real quick. It's still got a crappy cut on there. I'm going to face that off as well. Real fast. Close up. Machinists will think this is boring. People that don't know how to use these machines will think this is magic, like me. Okay. That was easy. So now we have the top of that faced off well. Another thing you should do while you have it in here is get a file and clean this up. I'm going to use both hands for this. You can go ahead and take your file, be damn careful. You can go ahead and just lightly pass it over the edge. And you leave this hand available to break free, because if this thing ever grabs onto it with the chuck, you can go ahead and let this thing just go. You don't try to manpower it, because you're not going to overpower the machine. But the whole point of that is just to clean up the edge so it's not sharp, okay? It's good, especially if you're going to give this to somebody else to handle. Some people don't, understand that raw machine steel is sharp as hell on the corners if it's fresh and it hasn't been deburred. So you don't want to hand parts over to people to check out, like say your friend's over. Deburr it before you hand it over to them. Don't expect people to use their brain. I'm actually going to do the same thing to this side really quick. Just real fast. That's it. Okay, now we've got one of these top pins, whatever we're going to call this. I'm going to come up with a name by the end of this project. So, got one of those done. Now we need to get that little guy back in there, chuck it up, and we're going to want to machine that down to 465 thousandths. Let me clean up this other edge real fast. And let's go back here. Okay. So right now, we're at 566 thousandths. So let's do some work. Now I want to have this particular tool able to do a nice finished corner on here, so when I press it in there it's good. So I'm going to increase this to 755 RPMs now. there's a little bit of wobble I can see visually in here. So I want to reset this thing and just take a look at it, make sure it's seated the way I want it to be. I'm going to move in 40 thousandths. Okay. 60 thousandths. Now we should, right about here, we should be about a ½ inch. We're going to do a quick measurement just to see if we're on track. Should be about a half an inch. We're 488 thousandths. So we're about 20 thousandths out. I'm gonna do a quick cleanup pass here. I'm gonna get this feed rate slowed down. Okay, I'll back this out, take another quick measurement. $479. $479 again. Let's go ahead and take, I'm going to go down to 465, so I'm going to take another 10 thou. $468 to $469. Try to take about 3 or 4 thousandths off real quick. Hold on a second. $466, $465. That's right where we want to be. Screw it. Let's make a cut. See what happens. Okay. So I'll pull this out. I'll take a quick look at our measurement. Get you guys in here for this. $464, $465, $464 and 5, $465. So that was our goal, 465 thousandths. Can I get this with my finger? That's the real question. it's going to get too tight. I will use the handle. A lot of the things that I've been pressing aren't this tight. That's some force, man. Gotta tighten that up again. That's all the way down now. So what happens with all that air pressure that's in that damn thing? So however many tons of pressure that just took, that means that thing's under all that pressure right now. Huh. I guess the friction of the fit is greater than the amount of force that's built up in air pressure. So is that acceptable? I'm borderline thinking it's not. What do you think? Fabricators out there, tell me what you think. I think we've got, I'm not crazy about that much wobble. If you can hear it doing this, that's not that great. I'd rather have it tight. Well, I appreciate you stopping by. Please subscribe, like, and share the video if you found it useful. And we'll see you on the next one. Here's a few photos from the weldtables.com website.